Given the function y equals to f of x, y prime is the same thing as the y dx, which is the same thing as f prime of x, is called the first derivative of the function. Y prime prime is the same thing as the square y over the x square equals to f prime prime of x, is called the second derivative of the function. Example of this is, given the function, find the square y and the x square of the function. Y equals to x to the power of 3 minus 2x squared plus x plus 4. What is y prime? Multiply it with the power and reduce the power by 1, minus multiply by the power and reduce the power by 1, plus multiply by the power and reduce the power by 1, plus the derivative of constants is 0. This is the same thing as 3x squared minus 4x plus 1. So the first derivative is this. What is going to be the y prime prime of this function? 3 multiplied by 2x minus 4. This is the same thing as 6x minus 4. So y prime prime is equals to 6x minus 4. Now, what is going to be y prime prime of 1? Y prime prime of 1, anywhere there is x, plug in x equals to 1. 6 multiplied by 1 minus 4. Y prime prime of 1 is equals to 6 minus 4, which is the same thing as 2. Extreme point and extreme value of a function. Extreme points are the points on the graph of a function where it reaches its highest maximum or lowest minimum value. There are two cases in this case. Case 1, if the curve peak, then we say we have a maximum extreme point. If the curve tips, then we say we have minimum extreme points. Case 1, if the curve peak, then we have a maximum extreme point. But if the curve tips, we have minimum extreme points. Or extreme points are the points on the graph of the function where the function takes its highest or lowest value. Given the function f of x equals to x squared, what is f of 0 of this function? 0 all square. This is the same thing as 0. That is, x naught comma f of x naught is equals to 0 comma 0. What is f of 1? F of 1 is equals to 1 squared, same thing as 1. X naught comma f of x naught, 1 comma 1. What is f of 2? F of 2 is 2 squared, which is equals to 4. X naught comma f of x naught. This is the same thing as 2 comma 4. F of 3, 3 squared, 9. F of 3 comma 3, 3 comma f of 3 is 3 comma 9. What is f of 4? F of 4 is 4 squared, which is the same thing as 16. 4 comma f of 4 is equals to 4 comma 16. F of minus 1 is equals to 1. So minus 1 comma 1 is equals to f of x naught. What is f of minus 2? F of minus 2 is minus 2 squared, which is equals to 4. In this case, we have minus 2 comma 4. What is f of minus 3? Minus 3 all square. This is equals to 9. This is minus 3 comma 9. So if you want to plot this in graph, this is x and y axis. Here is x axis. Here is y axis. Here is positive y axis. 4, 5, 6, 7, 8, 9. Here is positive x axis. 5, 6, 7, 8. Here is negative x axis. here is negative y-axis. So at point 0, 0, at point 0, 0, this is the origin. When x is 1, y is 1. When x is 2, y is 4. When x is 2, y is 4. When x is 3, y is 9. So this is the up here. When x is 4, y is 16. That is, if you extend this graph up, y is 16. So when x is minus 1, y is 1. When x is minus 2, y is 4. When x is minus 3, y is 9. So join the point together. This is how the graph look like. It's like a U shape. So at this point is the turning point of the graph, which is the 0, 0. So local minimum and maximum is saying that given the function x squared, what is y prime? This is 2x. At critical point, at the turning point, set y prime equals to 0. We call it a turning point of the function. This is equals to 0. That is, x equals to 0 is a critical point of this function, or is a turning point of this function. So differentiate the function second derivative. This is equals to 2. What is y prime prime at critical point? This is equals to 2, which is bigger than 0. Since y prime prime evaluates at critical point is bigger than 0, then we say this critical point is a local minimum for the what? For the function f. That is, at this point is the turning point of the function where this function has the least value, which is true. At any point of x, when x is 1, when x is minus 1, the function is always bigger than 0. So we say that at x equals to 0, f has its local minimum at that point. When differentiate the second derivative and evaluate at critical point and we have it to be less than 0, then we say at x naught, which is the critical point, y has its local maximum point. But at y prime prime and evaluate the y prime prime at critical point, if we have it to be equals to 0, then we say that the test is inconclusive. We have to use the fourth derivative to test the local minimum or maximum of the function. Given the function f of x equals to x squared minus 4x plus 3. In this case, what is the first derivative of this function? The first derivative of this function is 2x minus 4. At critical point, that is, at the turning point, set f prime equals to 0 and solve for x. This is 2x equals to 4, x equals to 2. Then this is x equals to 2 is called the critical point of this function. Then find the second derivative of the function. This is the first derivative. The second derivative is 2. Then evaluate the second derivative at critical point. This is the same thing as 2, bigger than 0. Then, since the second derivative evaluates at the critical point is bigger than 0, we say x equals to 0 is a local minimum point of the function. That is the point where f take the least value. Then we say f of 2 is called the local minimum value of the function. So what is f of 2 in this case? F of 2 is equals to 2 square minus 4 multiplied by 2 plus 3. This is 4 minus 8 plus 3 minus 4 plus 3. This is minus 1. So x naught comma f of x naught, which is equals to 2 comma minus 1, is called the local minimum point. Given the function f of x equals to x to the power of 5 plus x to the power of 3, what is going to be the first derivative of this function? 5x to the power of 4 plus 3x squared. At critical point, when the first derivative is equals to 0 is called the critical point. Then solve for x. Set the first derivative equals to 0. What is common here? X to the power of 2 is common. 5x plus 3, 5x squared plus 3 equals to 0. From here, either x squared is equals to 0 or 5x squared plus 3 equals to 0. X equals to 0 or 5x squared plus 3 is equals to 0. X is equals to 0 because 5x squared plus 3 can never be 0. So at this point, f prime prime of x is equals to 20x to the power of 3 plus 6x. Then what is f prime prime of 0? This is 20 multiplied by 0 cube plus 6 multiplied by 0, which is equals to 0. So the second derivative evaluated at point x equals to 0 is equals to 0. So at this point, the second derivative evaluated at this point is equals to 0. The test is inconclusive because the second derivative evaluated at x equals to 0 is equals to 0. So in this case, you are going to use the first derivative to test the local minimum or maximum point of this function. So in this case, at x equals to 0, x equals to 0 is a critical point of this function. So let's test this function using the first derivative before x equals to 0 and after x equals to 0. What happened to the first derivative of the function? X to the power of 3. In this case, f of minus 1 is equals to f of minus 1, plug in minus 1 here, plug in minus 1 here. Since here is even number and here is even number, the 1 minus 1 will be 1. 5 plus 3 is 8, bigger than 0. What if f of minus 2? F of minus 2 is equals to 5 multiplied by 16 plus 3 multiplied by 4, which is also bigger than 0. What is f of 1? F of 1 is 8, bigger than 0. F of 2 is equals to 5 multiplied by 16 plus 3 multiplied by 4, bigger than 0. So before and after the critical point, f prime evaluated at this is equals to a positive number. So in this case, no sign change. If the sign change from minus to positive when evaluated at, then we say we have local minimum point. If the sign change from positive to negative, then we have local maximum point. But if the have local minimum point. So by second derivative, we don't have local minimum or local maximum point. Using the first derivative, we don't have local minimum and local maximum point. The function only have critical point. There is no local minimum or local maximum point of the function. F of x equals to x to the power of 6 plus x to the power of 4. What is the first derivative of this function? This is 6x to the power of 5 plus 4x to the power of 3. Set this equals to 0 at critical point. X to the power of 5 plus 4x to the power of 3 equals to 0. This is called the turning point of the function. Then solve for x. What is common? 2x to the power of 3 is common. 3x squared plus 2 is equals to 0. Either 2x to the power of 3 is equals to 0 or the second bracket is equals to 0. Is equals to 0. 2x equals to 0 or 3x squared is plus 2 is equals to 0. X is equals to 0. 3x squared plus 2 can never be. So x equals to 0 is a critical point for the function. What is f prime prime of x? This is the same thing as 6 multiplied by 5 x to the power of 4 x to the power of 4 plus 4 multiplied by 3 x to the power of 2. This is 30 x to the power of 4 plus 12 x squared. What is f prime prime at critical point? 30 multiplied by 0 to the power of 4 plus 12 multiplied by 0 to the power of 2, which is equals to 0. Inconclusive, because f prime prime evaluate at critical point is equals to 0. So you are going to use the first derivative to find the local minimum, local maximum of the given function. F prime of x is equals to 6x to the power of 5 plus 4x to the power of 3. Then x equals to 0 is a critical point. Then check before and after this x naught. Here is -1, -2, 1, 2 to positive infinity and to minus infinity. What is f prime of -1? F prime of -1 is going to be 6 multiplied by -1 to the power of 5 plus 4 multiplied by -1 to the power of 3. Anytime here is odd, it will bring out the minus out. 4 multiplied by -1. This is -6 minus 4 equals to -10 less than 0. What is f prime of -2? F prime of -2 is going to be 6 multiplied by -2 to the power of 5 plus 4 multiplied by -2 to the power of 3. This is equals to 6 multiplied by -32 plus 4 multiplied by this is -244. F prime evaluated at -2 before the critical point. We have f prime before the critical point to be less than 0. After the critical point, let's examine the derivative at that point. F of 1 is equals to 10 bigger than 0. F prime of 2 is equals to 224 bigger than 0. Before the critical point, we have negative. After the critical point, we have positive. Then we say x equals to 0 is a local minimum for the function. F of 0 is going to be the local minimum value. So in this case, f of 0 is equals to 0, f of 0 is equals to x to the power of 6 plus x to the power of 4, which is equals to 0. At x equals to 0 is equals to 0, 0. So 0, 0 by first derivative test is a local minimum point for the function f of x equals to x to the power of 6 plus. So given the function f of x is same thing as y, the first thing is to find the first derivative, then set the first derivative of the function equals to 0, then solve for x. At this point, name the value of x as x naught. This is called the critical point, or is called the turning point of the function given. So the second is to find the second derivative of the function, which is same thing as f prime prime of x. Evaluate the second derivative at the critical point. Examine what happened. If evaluated the critical point is bigger than 0, then you say x naught is at local minimum point for the function. But when we evaluate the critical point at the second derivative and it is less than 0, then we say x naught is not just a critical point, but is a local maximum point for the function given. But when we evaluate the critical point and it's equals to 0, then the test is inconclusive. Then we use the first derivative to test for the local extreme point. Using the first derivative, given the function f of x, find the first derivative, then Set the first derivative equals to 0, solve for x, name the value as x naught. Then at x naught, let's say this is the critical point. Before the critical point and after the critical point, text what happened to first derivative of the function. Text f prime of x naught minus epsilon if it is less than 0. Text f prime of x naught plus epsilon if it is bigger than 0. That means before the critical point it was negative and after the critical point it was positive. Then x naught is a local minimum point. But when we test the x naught minus epsilon is bigger than 0 and f prime of x naught plus epsilon and it is less than 0, that is, it change from positive to negative, then we say x naught is at local maximum point for the function. But when we test for f prime of x naught minus epsilon is equals to 0, or when it is bigger than 0 and f prime x naught plus epsilon and it is still bigger than 0, no sign change from positive to negative or negative to positive. It's either is positive positive after and before the critical point or negative negative after and before the critical point. Then we say the test is also inconclusive test.